Jeez. Alright, so to solve this, what do I have to do first? What do we got to do? Rearrange it. I got to rearrange it. Get your x's on your x's, your y's on your y's. So I'm going to get negative 6x plus 4y equals negative 30. 8x minus 7y equals 25. Now we can start eliminating stuff. What do you want to eliminate? The y's? Okay. So if I eliminate the y's, what am I going to multiply the top and the bottom by? 7 and 4. Okay. I am going to go ahead and do that. If I wanted to eliminate the x's, what could I have multiplied by? 4 and 3 would have gotten me to 24. You also could have just done 8 and 6 and you've ended up at 48. Either way. Alright, so I got negative 42x plus 28y equals negative 210. And 32x minus 28y equals 100. Put those together and I get negative 10x equals negative 100. X equals, that should be 110. X equals 11. We'll then plug 11 into something we haven't messed with yet. So plug it into the top or the bottom? Top, okay. So I have negative 6 times 11 equals negative 4y minus 30. So negative 66 equals negative 4y minus 30. Negative 36 equals negative 4y. Y equals 9. Okay. Now, we didn't really talk a whole lot about solving these in the calculator because I'm more concerned about you knowing the math. But if you do this in the calculator, okay, and the point that it's going to intersect is at 9, 11. Okay? Or, I'm sorry, 11, 9. 11, 9 is not going to show on this screen because it's 10 by 10. Okay? So 11, 9 is going to be like right here. And when you do second calc 5 enter, it's probably going to come back and say error or say quit. Okay? It's not going to give you the intersection. That's because it can't see it. Okay? It can only see what's on this screen here. So if your eyeballs can't see it, it can't see it. So what you would have to do is zoom out. You do zoom 3 enter or zoom 0 enter so that you, with your eyeballs, can see the intersection. So when you can see it, the calculator can see it, and then you can run the intersection. Does that make sense? Okay? Because on your test, there is a substitution one, there is an elimination one. Say you screw something up and you just keep ending up with strange numbers or whatever, and you can't figure out what the answer is. You can go ahead and graph it and at least get the answer. You're not going to get full credit for it, because I want to know if you can do substitution and elimination, but you'll at least get something. Okay? Does that make sense? Alright. So, the next one we have here is inequalities. So, I have y is greater than or equal to negative 3. X is less than 4. And 2y is greater than 4x minus 6. Okay. So for y is greater than or equal to negative 3, how are we going to shade? Up or down? Up. Y is positive, so we're going to shade up. For x is less than 4, how are we going to shade? Down, which would mean smaller numbers, which would be to the left. And what about for 2y is greater than 4x minus 6? Oh, because your y is positive. Alright, so I have y is greater than or equal to negative 3. So I have a line under my equal to. I have a line which means it's or equal to. So I have a solid line at -3. And I'm going to shade up above that. Okay, shade up above that. Okay. And then I have x is less than 4. So there's not a line under it, so I have a dashed line at 4. And we're going to shade to the left of that. So over here. Okay. And then I'm going to go ahead and put this in slope-intercept form. I have y is greater than 2x minus 3. So and we have a dashed line there. And we're shading up above that. So the area where we have shaded 3 times is the solution to that system of inequalities. Now, I don't think I showed you this, but I'm actually going to show you what happens with that triple shaded region. Okay, so I say that, it has to make all 3 things true, right? In order for it to solve the system. So I'm going to take this point right here, and that's at 5, 0, okay? 5, 0, that's my point. And I'm going to start plugging it in to these inequalities up here. So the first one I plug